We have all seen the magic trick by now, right? I mean, you sit down at your keyboard, you type a plain English sentence into a prompt, and like seconds later, a fully working software function is just staring back at you.
Yeah, it really does feel like magic the first time you see it.
It totally does. It feels like we're entering this whole new era of invisible code,
Yeah.
where you and I, humans, we just provide this grand vision, and the machine handles all the messy structural details underneath.
Right. It's a really seductive vision. I mean, watching these large language models instantly spin up complex boilerplate code, it looks like absolute sorcery from the outside. And the tech industry naturally gravitates toward, well, anything that promises effortless scale.
Exactly. But today, for you, our listener, we're going deep into why that magic trick might actually be, an illusion.
Or at least a lot more complicated than it looks on the surface.
Yeah, definitely. So we're pulling from a really fascinating article published today, August 4, 2026, in Tech Reader magazine. It's written by Aaron Rose, and it's called Why Humans Still Matter in the Age of AI-Generated Code.
Which is such a timely piece because it tackles this widespread anxiety that's just circulating everywhere in the tech world right now.
Massive anxiety.
Yeah, this looming fear that AI is just going to wholesale replace the developer. But Rose argues that the reality of the situation is, well, it's much more nuanced than a simple replacement narrative.
Right. And so the mission of our deep dive today is to really explore that argument. We want to look at why AI might not be replacing the developer, but rather like fundamentally redefining what the role even is, and why reading code instead of just writing it is about to become an absolute human superpower.
It really is.
Okay, let's unpack this. I want to start with this gap between the myth of the autopilot and the reality of the co-pilot.
Yeah, that's a crucial distinction. The autopilot myth basically suggests you can just hit a button, walk away to get a coffee, and the software builds itself.
Which would be nice, but yeah.
Right. But if we look at the current reality of developer workflows today, we're dealing with tools like GitHub Copilot and, various chat-based coding assistants.
And they're doing some heavy lifting, for sure.
Oh, absolutely. They're deeply embedded in the daily grind. They're handling auto-completions, suggesting fixes, generating entire test suites in seconds.
Right. For routine, repetitive tasks, the volume of text these tools output is just incredible. It actually makes me think of an analogy. Using these AI tools right now, to me, feels a bit like managing a hyper-caffeinated intern.
A hyper-caffeinated intern. I like that.
Yeah, because you have someone who types incredibly fast, they're super eager to produce, and they can churn out pages of syntax in seconds. But they don't actually understand the company culture or the history of the product. They're just kind of throwing code at the wall at light speed.
What's fascinating here is how that analogy perfectly mirrors the core technical friction point that Rose highlights in the article. Because AI writes fast, but it doesn't comprehend fast.
Okay, wait, break that down for me.
Well, they're fundamentally different processes, right? A large language model doesn't actually think about logic. It relies on token prediction.
Just guessing the next word.
Exactly. It maps statistical probabilities across these vast neural networks to determine, which character or word is most likely to follow the previous one based on its training data.
Meaning every single line that our hyper-caffeinated intern generates still needs a human mind to review it.
100%. The developer still has to check all the dependencies. They have to question the edge cases because the machine isn't reasoning about the architecture of your app.
It's just playing a highly advanced game of autocomplete.
Right. Brilliance at generating syntax is not the same thing as comprehending how that syntax is going to behave in a live, messy production environment.
Yeah, that makes sense.
Like, the AI calculates that a specific database query looks statistically correct, but it doesn't understand the physical constraints of the actual server that has to execute that query.
Okay, I hear you, but I'm struggling to fully understand this supposed limitation, though. Let me push back for a second.
Sure, go for it.
If I take my entire company's code base, right, all of it, and I feed it into an enterprise AI model, doesn't it then have my context? I mean, it could literally read every single line of code my team has ever written. So why is there still a disconnect?
So that brings us directly to what Rose refers to as the context gap.
The context gap.
Yeah. Feeding an AI your repository gives it your syntax patterns, sure. But code is not just isolated logic. Code is history.
Oh, I like that. code is history.
Code is human intent. Even with something like retrieval augmented generation, where the AI is actively searching your specific code base for context, it's still operating within a limited context window.
Right, it can only hold so much in its memory at one time.
Exactly. It can only hold so many tokens. But more importantly than that, it only has access to what is explicitly written down.
Meaning it doesn't know the unwritten rule.
Exactly. The AI doesn't know your company's risk tolerance. It hasn't experienced the 5 years of painful trial and error that led your engineering team to finally adopt certain architectural patterns.
It just sees the end result of all that suffering.
Yes, it just sees the final product of the struggle.
It definitely doesn't know about, like, that one terrifying legacy server sitting down in the basement that everyone in the office actively avoids touching.
Right, the forbidden server. And AI will blindly suggest integrating with that fragile legacy system because mathematically, the API connection makes perfect sense.
But the humans know better.
Right, because the AI lacks the localized history to know that touching that specific system on a random Thursday triggers a cascading failure that brings down the whole corporate network.
There's actually a highly specific scenario in the article that illustrates this perfectly. Rose mentions that an AI doesn't know a certain network endpoint is slow because of a flaky third-party API that only acts up on Tuesdays.
Yes, the Tuesday bug. A human developer who was on call during a massive system outage on a Tuesday, they remember that in their bones.
Oh yeah, they have the trauma.
Right. They understand the underlying mechanism. Like maybe that third-party vendor runs massive batch processing jobs every Tuesday afternoon, which throttles the bandwidth and causes timeouts.
But the AI just sees a standard HTTPS request in the code.
Exactly. It doesn't read the business logic that's hidden away in like fragmented Slack threads or the complaints from a Sprint retrospective meeting 3 months ago.
Wow, yeah. The context gap feels massive when you frame it through the lens of lived experience versus just statistical prediction.
It really is.
It's basically the difference between knowing the dictionary definition of a word and understanding all the cultural baggage attached to it.
That's a great way to put it. And that gap becomes a genuine liability when we look at how software interacts with the real world, particularly concerning security and, well, edge cases.
Okay, this is where I find myself getting hung up again.
How so?
Well, if the AI is trained on all the best, most widely used open source code in the entire world, shouldn't it naturally default to the most secure, bulletproof option?
You would think so.
Right. Shouldn't the sheer volume of training data create this, like, wisdom of the crowds effect that makes the code inherently safe?
It is a totally reasonable assumption to make, but it fundamentally misinterprets how machine learning models actually weigh information. AI works on averages, not outliers.
Averages, not outliers. Okay.
Right. It predicts the most common solution. And in the software supply chain, popularity absolutely does not equal security.
Interesting. How does that actually play out in a daily coding scenario, though?
Let's say you ask the AI to build a user authentication module for you. The AI is very likely going to suggest importing the most heavily downloaded cryptographic library from, say, the last 5 years.
Because it's popular.
Because it's everywhere in the training data. However, that specific library might have a newly discovered, highly publicized zero-day vulnerability.
Oh, wow.
Right. And the AI doesn't natively cross-reference its text generation with live security databases in real time unless a secondary tool is explicitly forcing it to.
So it just hands you broken code.
It serves up the vulnerable code because its pattern matching simply dictates, hey, this is the library developers usually type next.
It's parroting the crowd, even if the crowd is currently using a severely outdated lock on their front door.
Exactly. Furthermore, an LLM won't necessarily flag dangerous behavior unless it's been explicitly fine-tuned to spot that exact pattern.
Like what kind of behavior?
Well, if your generated code accidentally takes sensitive user data, like a plain text password, for example, and logs it into a temporary storage file just for debugging, the AI might not recognize the ethical or legal violation there.
Because to the AI, it's just moving text around.
Syntactically, yeah. It's
Right.
simply moving a string of characters from point A to point B. It requires a human to actually look at the data flow and ask, wait, should this highly sensitive information exist in this location under current privacy laws?
Right. That covers the security blind spots pretty well. But the article also points out that edge cases are a massive weakness for AI-generated code.
Absolutely. Because AI trains on common paths, it struggles with rare failures. Rose actually uses this great example of a 2 GB thumbnail to explain this.
Yes. The 2GB thumbnail scenario. Walk us through that.
So if you use AI to quickly write a microservice that just processes profile image uploads, the resulting syntax might be flawless for a standard everyday workflow.
Right. The AI anticipates a user uploading a normal 2 MB JPEG.
Exactly. But the model will very likely fail to implement safeguards for what happens when a malicious or honestly just highly confused user attempts to push a massive 2 GB file into that tiny service meant for thumbnail.
Because the average pattern is a small file, the AI is optimizing entirely for the happy path.
Precisely. And when that 2 GB file hits the server in reality, it consumes all the allocated memory in the heap, causing the entire container to crash.
Total disaster.
Or consider race conditions.
Oh, those are fun.
Right. A race condition happens when two different parts of your software try to access and change the exact same piece of data at the exact same millisecond. In a local testing environment where you just have one user clicking around, the AI's code behaves perfectly. But put that code in production under the heavy load of 10,000 simultaneous users, and the mathematical probability of two threads colliding just spikes, which can completely corrupt your database.
And the machine just cannot easily predict that runtime behavior just by looking at static text in a prompt.
No. Human developers know to protect against memory leaks and race conditions because they have personally been burned by them before.
The trauma again.
It really is. Experience in software engineering is largely just the process of surviving edge cases.
Which brings up, I think, the most crucial takeaway from this whole section of Rose's argument. AI generates the code, but humans own it.
Yes. The legal liability, the ethical responsibility, the 3.00 AM PagerDuty when everything goes down, none of that can be outsourced to an algorithm.
No one's waking the AI up at 3 a.m.
Exactly. The burden of ownership sits squarely on human shoulders.
So what does this all mean for us? Because if we are ultimately the owners and the liability falls entirely on us, the fundamental job description of a developer is undergoing a massive shift right now.
It is.
We're moving from being purely creators to becoming curators. It sounds almost like the transition from being a bricklayer to becoming a city planner.
I love that analogy. As a bricklayer, your focus is entirely micro. You are deeply concerned with placing one single brick of syntax perfectly on top of another, managing semicolons and building loop structures.
But as a city planner,
your perspective zooms out to the macro level. You are looking at how data actually flows through the entire infrastructure. You are anticipating traffic bottlenecks and zoning issues.
right,
Rose actually refers to this elevated perspective as code stewardship.
code stewardship.
Yes. Reading code deliberately is becoming a massive superpower. It's akin to an architect reviewing a building's blueprint before actually pouring the concrete, or like a forensic accountant auditing a complex financial statement.
The source actually points out that code reviews, the process where developers check each other's work before merging it, those are going to take on a whole new level of importance.
Oh, absolutely.
They aren't just for catching a miscomma or a minor bug anymore, right? Because the AI is already handling the basic spell check level of syntax.
Exactly. The code review is shifting heavily toward cultural alignment and architectural integrity. It's where senior developers teach junior developers how to think about the system as a whole.
It's where those unwritten rules we discussed earlier actually get transferred.
Spot on. An AI can suggest a mathematically efficient sorting algorithm in 2 seconds, sure, but it cannot teach a junior engineer how to communicate technical trade-offs to a non-technical product manager.
Right. And when a complex system inevitably fails in production, it's the steward who fixes it, not the AI. It's the person who actually took the time to trace the paths of that code and understand the full context.
Because the steward knows the history behind the error. When they look at a broken system, they don't just see a failed function. They see, the architectural compromises that were made 3 years ago just to meet a crazy launch deadline, which finally buckled under pressure today.
Wow, yeah. Rose also introduces this concept, the 80-20 rule, for this new AI-augmented reality.
Right. The argument there is that AI will eventually generate about 80% of the boilerplate, the repetitive, tedious scaffolding required to stand up any modern software project.
The boring stuff.
The boring stuff, exactly. But humans will absolutely retain ownership of the critical 20%.
Which is?
That includes the core business logic, the strict security boundaries, and the nuanced user experience constraints.
It's like just because we have advanced CAD software today, computer-aided design, we didn't just fire all the master builders and architects.
Right. If anything, we need them more than ever to read the schematics, reason about the materials being used, and decide what actually gets built in the physical world.
Because as the speed of generation increases, the blast radius of a mistake expands too. You need human judgment as a governor on that sheer speed.
You really do.
So if we apply this stewardship mindset to a daily workflow, how does a developer actually survive and thrive in this environment right now? Rose maps out a practical methodology for this, right? Integrating this mindset on the ground.
He does. And the first major workflow adjustment is treating all AI output purely as a first draft.
Going back to our hyper-caffeinated intern,
Uh-huh.
you wouldn't take their unedited raw brainstorm and push directly to the live company homepage.
Definitely not. You have to assume every single suggestion requires an architectural review. The developer has to actively question if the AI solution actually aligns with the team's established design patterns.
Right.
Because AI has a severe tendency to hallucinate complexity, so you always have to ask, is this over-engineered? Could it be simplified?
Keep it simple.
Yes. The foundational rule of stewardship is to never merge code simply because it executes without throwing an immediate error.
That is such a good rule. Now, the second workflow adjustment deals directly with those security blind spots we covered earlier.
Right.
Developers have to rigidly audit their dependencies.
You cannot assume the AI shares your organizational security context. When it suggests importing some random external library, the steward has to verify its integrity.
Like, is the repository actively maintained by its creators? Does it have known vulnerabilities?
Exactly. Developers need to actively use tools like NTM audit or Snake.
Just to clarify for those listening who might not be deep in the weeds on this stuff, when you use tools like NPM Audit or SNCC, you aren't just checking the syntax of your own code.
Right.
You're actively cross-referencing your AI's library suggestions against live, global vulnerability databases to ensure you aren't literally importing known malware into your app.
Exactly that. It is a vital step. And the third workflow adjustment is a total shift in how testing is approached.
Because the AI trains on the happy common paths.
Right. So the human must aggressively test the edge cases.
You have to be the one to anticipate the weird stuff.
Okay.
Writing tests for sudden spikes in server load, or bizarre user input, or incredibly slow mobile network connections in the middle of nowhere. The steward guards the boundaries of the system.
They do.
Now, here's where it gets really interesting to me. Rose suggests flipping the dynamic entirely. Instead of just using AI to generate new code, developers should aggressively use it to explain existing code.
Which is brilliant. It repositions the tool from being just a generator to being a tutor.
Yeah. If I'm inheriting a massive, undocumented legacy code base tomorrow, I can drop a really confusing block of code into the chat assistant and just ask it to break down the logic step by step.
It's an incredible time saver.
It seems like an incredibly powerful way to catch logic errors or just build your own mental model of a system you didn't even write.
It really leverages the AI's pattern recognition to translate obscure syntax back into plain English, which drastically accelerates the human's ability to act as a proper steward.
Yeah, that's huge.
And the final workflow adjustment Rose highlights is perhaps the most critical for long-term sustainability, which is keeping the why in your code.
Because the AI cannot document human intent.
Exactly. The machine only knows what it wrote. It has zero concept of why it was asked to write it in the first place.
Right.
Therefore, a developer's comments, their commit messages, and their documentation, all of that must pivot away from describing what the code does. The AI can read the what easily.
Sure.
It has to focus entirely on the architectural reasoning. Why did the team choose this specific database structure? Why was a certain performance trade-off accepted just to meet a deadline?
Because documenting the intent is how you future-proof the project for the rest of your team. You have to stay curious and interrogate the output. A steward cannot get complacent and just click accept on the first prompt that runs cleanly.
Right. The most effective engineers are going to use AI to explore alternatives, continually prompting the model to see if there is a more efficient or more readable way to solve a problem, rather than just, using it to get to the finish line as fast as humanly possible.
So, bringing it all together, the core message of Rose's piece is that the future of coding is not code-free.
Not at all.
It is about moving up the stack. It's spending less time on the mindless repetition, the boilerplate, the mortar between the bricks, and spending significantly more time on the meaning and the architecture of the city itself.
Because software infrastructure shapes the entire modern world. I mean, from banking to healthcare to global logistics.
Everything.
And as long as that remains true, we're going to require humans who deeply understand how those systems function under immense pressure. Someone has to keep the lights on and curate the digital infrastructure we all rely on.
We are officially stepping into the role of the code keeper.
It's a profound shift in responsibility, though, analyzing this transition towards stewardship does raise one really important question.
Oh.
It's something to seriously ponder as the industry continues to evolve.
Wayame.
Well, if AI gradually takes over generating all the what, the actual syntax, the boilerplate, the foundational building blocks, and leaves humans entirely in charge of the why, the intent, and the curation.
Yeah.
What happens to the tech industry in 10 or 15 years? We are looking at a potential future with a whole new generation of developers who may never actually build the what from scratch.
Wow. That is a really sobering thought. We might literally be engineering away the very struggle that creates mastery in the first place.
Right. How do you effectively curate a museum if you have never had to paint a picture yourself?
Oh, that's good.
Can someone truly be a master steward of complex, distributed systems if they didn't have to suffer through laying those structural bricks by hand early in their career? It is a dynamic we will absolutely have to monitor very closely as we navigate this new frontier.
How do you curate a museum if you have never painted a picture? That is going to stick with me. Thank you for joining us on this deep dive today. Keep asking those hard questions in your own work. Keep guarding those edge cases. And remember, just because the code looks invisible doesn't mean the magic trick is real. Until next time.